The next two classes of objects that we're going to look at are matrices and arrays. A matrix is a two-dimensional structure of data elements. You can envision a matrix as rows or columns of atomic vectors. Furthermore, each of those atomic vectors need to be of the same data type. That is, the matrix itself is atomic as a whole. You could envision an Excel spreadsheet, for example, in which you have rows and columns. That would be a matrix as long as every cell had the same type of data in it, all integers or all doubles or all characters or all logicals. As you know, when you work in Excel spreadsheets, you can put different types of data in different cells. So not all Excel spreadsheets are going to be matrices. But if you have all the same data type throughout the spreadsheet, then it could be a matrix. A matrix can be created by giving two dimensions to a vector. As we will see, there are multiple ways to create matrices, but the key is that a matrix has a dimensional attribute, namely 2 dimensions. Now, a vector also has a dimensional attribute. It has 1 dimension. But we noticed that when we look at the attributes of a vector, because it just has 1 dimension, dimension is not even listed as an attribute for a vector. But you can think of that as an unnamed or unlisted attribute of 1 dimension. Now we're going to expand it to 2. What if we want to go beyond 2? That's an array. An array is a data structure with more than 2 dimensions. So you can think of an array as a multi-dimensional series of atomic vectors. Another way I think of an array as a series of matrices extending it to another dimension. It's pretty easy for me to think about an array in 3 dimensions. So you could have data going up along one axis, a vertical axis, and then a horizontal axis, and then you could think of some depth to that. But once I get beyond 3 dimensions, arrays can go there, but my brain cannot. Anytime you have more than 2 dimensions, this is an array as long as, again, it's atomic. That is, every data element within the array, in order for it to be an array, has to be of the same data type. An array can be created by giving more than 2 dimensions to a vector, and we have other ways of creating arrays as well that you will see. Arrays have a dimensional attribute, namely the dimension will be greater than 2. You can kind of think of matrices as a subset of arrays. That is, if you think of arrays as the general, where you have as many dimensions as you want, a matrix has 2 dimensions. Because matrices are so special in statistical analysis, we will look at that in the future, not in this learning cycle. But because they're so special in statistical analysis, it's appropriate to retain that special name of matrix rather than lumping everything together here under array. Let's look at our notebook now and talk about matrices and arrays in some more detail. Remember that a matrix is a 2-dimensional object in which every data element is the same as every other data element. So matrices are atomic, and then an array, of course, is an extension of the matrix. So here is a vector, student scores. Now, I could have created this vector with putting these all on the same row, all these data elements on one line. I did it this way on purpose because I'm going to create a matrix from this in which each of these first 4 elements are going to be 1 column, each of the next 4, the next column, and each of the next 4, the next column. That is, when I create this as a matrix, This is done with columns being created first and then rows. So those first 4, even though they're on one row, they're actually going to be in one column when we're done. So let me go ahead and create that vector. So there's nothing special right now. If I were to type in student scores, you'll see one vector of values. What makes it a matrix is when I give that 2 dimensions, and that's what I'm doing here with the dim function. I'm creating 2 dimensions, and what this is telling me to do is to create 4 rows and 3 columns. We always put rows first and then the number of columns. Now notice 4 rows, 3 columns. Up here, the way I have it laid out is it looks like we're going to have 3 rows, 4 columns, but the way the matrix will actually be created is column by column. So it's going to create those 3 columns, column by column. That can be a little bit confusing, but that's the way it happens here. And so when I look at the matrix, it looks like this. Here's 1, 2, 3, 4. So the first row went into the first column, and then 47, 51, 55, 45, and so on. So this is considered a 4 by 3 matrix. You say the row dimension first and the column dimension second. Here's another way to enter data. We can actually use a matrix function and skip the step of creating a vector first. So I'm using the matrix function, but within the function I have a function, namely the concatenate. So it's like creating that vector within and then use the matrix function to create it as a matrix. I'm stating here that the number of rows are going to be 4, the number of columns are going to be 3, just like I did before. So I end up with the exact same thing I had before. Now the default, as I've mentioned, is to enter data in columns first, but notice what we could do that might make more sense in terms of laying out our data so it's not so counterintuitive. If we set a new argument to our matrix function called by row equal to true, the default is that that argument is false, and so the data are entered by columns. But if we set by row equal to true, then it will enter into rows. And so this now is going to create row 147, 41 if you look over here in the console, just like we had it before. So we're entering the data now, the same data, but in a different way, and you see that we get the same matrix. So it's really up to you which way you use to enter these data. Now let's look at the class and the other attributes of a matrix. So starting with class, the class is a matrix or array. It doesn't distinguish between which one it is. So anytime you will ask for the class of a matrix or array, this is what you're going to get. Remember, a matrix is kind of like a subset of arrays. If I look at the attributes include a dimension. With vectors, it did not tell us that there was one dimension. But here we can see that there are 2 dimensions because there are 2 numbers. And the first number is telling us how many rows there are. The second, how many columns there are. Let's look at the type of. That just tells us what type of data we have in every cell, in every element of the matrix. Remember, they all have to be of the same type, so this will simply be a single data type that we discover here. We can ask if it is numeric. Yes, it is. We can ask if this is a matrix. Yes, it is. And we can ask for the length of what's in the matrix, and it treats it just like if this had been in a vector. So even though we have 4 rows and 3 columns, 4 times 3 is 12. There are 12 elements, and so we have 12 given back. You can think of this as having a vector that is telling R to treat it as though it's a vector that's now been remanipulated into the different rows and the different columns. We can add names to our dimensions. So let's look at our 4 rows. Let's call those 4 rows A, B, C, D, and let's suppose that in our columns we have an ID for the student, and then a math score, and then a reading score. So now my matrix looks like this. The same data, but now I actually have names for the rows and names for the columns. I can, just like with a vector, provide a comment. If I now look at the attributes, I see that I have dimensions, I have names to the dimensions, and notice this is a little bit of a peculiar notation you're going to learn about later in the course. But for now, note that the dimension names are for the first dimension in that funny looking double bracket, the first dimension 1, A, B, C, D, and the dimension names for the second dimension 2, ID, math, and reading. Here's my comment, and I actually have 2 comments, data from the 3rd grade study and collected on the 15th of November 2018. If we decide the names don't add much, we can use the same functions, row names and col names, and set them to null. Null means nothing. So that's how we get rid of names. There's not a separate function to say eliminate names. It's just row names is going to be set to null. So now when I look at this, I have no A, B, C, D, but the column names are still there because I did not set those to null.